Well, look at you. You made it to lesson 5.6, triangles in the coordinate plane. And I bet you're thinking you're pretty cool. Well, you are, because you made it. And you should be proud of yourself because this is the last lesson in the unit. So, what are we going to be doing? We're going to be putting some triangles on the coordinate planes and we're going to be classifying them. I know, I know. Hold down, it's about to happen. So let's just do a little reminder on what the different kind of triangles are, okay? There's scalene, isosceles, and equilateral. Scalene, no equal sides, no equal angles. Isosceles, two equal sides and two equal angles. And equilateral is three congruent sides, or three equal sides, and three equal angles. Now, another thing I should probably remind you about is the distance formula, okay? If you remember this from last time, it's just d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. All right, that is our distance formula. How is that going to help us today? You're about to find out. Well, the first thing we're going to do is classify. And what do we mean by classify? Classify just means we're going to figure out what kind of triangle this is, okay? So we're going to classify the triangle with the vertices at the following points as either equilateral, isosceles, or scalene. So if it's equilateral, we'll see that it has three equal sides. Isosceles will have two equal sides, and if it's scalene, it'll have no equal sides. The vertices, or the angles, are at A, B, and C, and here are our coordinates. So the first thing we should probably do is just graph it out, okay? A is at -1, 8, all right, which is over here. B is at -5, 2. Well, that's 3, 4, 5, 1, 2. And C is at 5, 4. So that's 1, 2, 3, 4, 5, 1, 2, 3, 4. And what a pretty looking triangle we found ourselves with. You guys should probably take out your protractors, draw yourself a nice little triangle here. And don't forget at the end of this to label your points. It's going to help you a ton. So this was our A coordinate, this is our B coordinate, and this is our C coordinate. Now it's kind of hard to tell from looking what kind of triangle this is, so the best thing we have to do is actually find the side lengths. And we could do that by using the distance formula. We can find the distance from A to B, A to C, and B to C, and find out what these side lengths actually are. So let's just go ahead and do that. We'll find the side length AB first, okay? And we do that by just finding the length subtracting the x's, x1 minus x2, so that's -1 minus -5, and we subtract our y's, 8 minus 2. Well, when we do this -1 minus -5, don't forget your extra negatives in there. We get 4, so this is d is going to be equal to 4 squared, plus 8 minus 2 is 6 squared. D is going to be equal to 16 minus 30 plus 36, and so our D is going to be equal to 52. Now finally we take the square root. So this is going to be the square root of 52. Don't forget that square root at the end. Next we're going to find AC. Alright, so we're just going to erase this and we have our AC now. So x1, y1, x2, y2. We start by subtracting our two x's, -1 minus 5, and we subtract our y's, 8 minus, where am I writing this? -1 minus 5, and 8 minus 4. When we do that, we get -6 squared plus 8 minus 4, which is 4 squared. And that's going to be our distance. We get D is equal to 36 plus 16, which is once again 52, which we have to take the square root of. So we know that AC is also 52. Alright, well we know we have at least two sides that are the same. Finally we find the third side. So start all over again, finding our distance. x1, y1, x2, y2. So in this case we get -5 minus 5, and we get 2 minus 4. Put this into the distance formula. Negative 5 minus 5 is negative 10 squared plus 2 minus 4, which is just negative 2 squared. D is equal to 100 plus 4, which just gives us 104. And don't forget to take the square root at the end. So this is the square root of 104. Now looking at these three, we have two equal sides, two congruent sides, and one that's not congruent. So what kind of triangle is that? You called it, that is isosceles. And that's all you have to do. Find the lengths of the three sides and just compare them. 3 equal sides, 2 equal sides, or no equal sides. And that's how we name it. Well, once again, if we wanted to classify a triangle, we're just going to have to do the same thing. Classify the triangle with these vertices, C, A, and T, and see if its equilateral isosceles are scalene. Now, for those of you who totally understood what I just said, fast forward and just go to the next problem. For those of you who want a little extra practice, stay along with me, we'll figure it out. So first thing we do is just graph the points out. So we have C, which is negative 2, negative 3. All right, right over here. We have A, which is 0, 5. 0, 1, 2, 3, 4, 5. And we have T, which is 3, 0. Okay, let's draw our lines from here to here, from here to here, and from here to here. Now don't forget to label your vertices again. So we have C over here, A, and T. Now once again, it's kind of hard to tell by looking at it, so we'll just have to find the distances. And let's start with CA. So we subtract the two x's, which is negative 2, and we're using C and A to start, C and A. So negative 2 minus 0, just subtract our two x's, and we subtract our two y's, negative 3 minus 5. When we do that, we get negative 2 squared plus negative 8 squared, and that means we get D equals 4 plus 64, which is equal to 68, and don't forget to take the square root at the end. 68 square root. Oh, wrong place. CA. Oh, 68. All right, our next one, AT. All right, so we're going to subtract our x's, that's 0 minus 3. And we subtract our y's, 5 minus 0. So D is equal to negative 3 squared plus 5 squared. D is equal to 9 plus 25, which is equal to 34. We take the square root, and AT is equal to the square root of 34. All right, nothing that's the same yet. And finally, CT. So we subtract the x's, negative 2 minus 3. Okay, then we subtract our y's, negative 3 minus 0. When we do that, we get D is equal to negative 5 squared plus negative 3 squared. D is equal to 25 plus 9, which gives us 34. We take the square root, and what do we get? 34. So once again, looking at this, we see that we have two congruent sides, and that makes it an isosceles triangle. All right, finally we're going to be doing our challenge problem. Bear with me, I think together we can handle this. In triangle ABC, we have A equals 0, 4, B equals 2, negative 4, and C equals 6, 2. We want to find the length of the midsegment parallel to AB in triangle ABC. All right, I think together we can handle this. Let's start by drawing it out. So A is 0, 4. Okay, that's right here, and that's our A. B is 2, negative 4, which is right over here. And C is going to be 6, 1, 2, 3, 4, 5, 6, 2. All right, now you guys should grab out your protractors. Let's draw out this triangle, connect the sides. Okay, connecting, connecting, connecting. Beautiful. A, B, and C. Okay, now we want to find the midsegment parallel to AB. So we're going to find the midpoint of AC and the midpoint of BC to be able to do that and find out what this line, wherever it may be, is. Okay, that's going to be our midsegment. So we need to find our midpoints. So the midpoint of CA, well, remember we just add our x's divided by 2 and add our y's and divide by 2. So the midpoint of CA is going to be equal to 6 plus 0 divided by 2, comma, 2 plus 4 divided by 2. And that's just adding our x's and adding our y's, okay? So when we do that, 6 plus 0, well, that's 6 divided by 2 is 3. Once again, 2 plus 4 is 6, divided by 2 is 3, so our first midpoint is at 3, 3. That's the midpoint of CA. 1, 2, 3. 1, 2, 3. The second midpoint we have to find is CB, okay? So we're going to find our midpoint. We're going to add our x's. 6 plus 2. 6 plus 2 divided by 2. And we're going to add our y's. Negative 4 plus 2. All right, negative 4 plus 2. And divide that by 2. All right, we find our midpoint. 6 plus 2 is 4. Divided by 2 is 4. And negative 4 plus 2 is negative 2. Oh, divided by 2 is negative 1. That is our second midpoint, so we just count that out. 1, 2, 3, 4, minus 1. And that is our other midpoint. Now that we have our midpoints, all we have to do is connect that line. That is going to be our midsegment. Remember, a midsegment is just the line that connects your two midpoints. And what we're trying to do is find the distance or the length of our midsegment. Well, we have our 2 points of our midpoints, and all we have to do is find the distance between those two. And you know what? I think you guys can handle that. I'll have the answer for you on the answer key, but from this point forward, I want you to find the length of this midsegment using the distance formula and these 2 points. And that will be its length. All right, guys, good luck. I'm going to retire for the evening, and remember, don't sit on your glasses, because then you have to go to the glasses repair store really early in the morning on Monday, and that's just no fun. Don't ask.